Okay, welcome back. So now we've got an important idea of what happens when we are dealing with this coefficient, and this refers to the period. So we're going to reference this as the period, and the period will change depending on what the coefficient is. Okay. Sorry, our computer gets very, very busy. So the period. Now the period has an equation, and the equation is 2 pi over b, 2 pi over b. And so 2 pi divided by b, it will be your period. Okay, 2 pi divided by b. So, interestingly, this is not straightforward. Okay, the period 2 pi over b is something that you will need to learn to use fairly quickly. But as in all things, what's the intuition? If we increase that up to 2, what does that have the effect of doing to the period? Well, it has the effective period of making it finish earlier. So I'm going to ask you to use specific language. Okay, earlier and later. Earlier and later. So in this case here, it finishes earlier. Oh, okay. Finishes earlier. So if it finishes earlier, just getting fed up with that. Quickly as I would like it to. So it finishes earlier. Okay. So that means this one's still going, sin x is still going, and the other one, the red one's finished. Oh, that's already done. So that's the effect of increasing this. And what about if it's fractional? What about if that's fractional? What does that do? What does that have? So instead of finishing earlier, it'll be finishing later. And they're all relative, of course, relative to the baseline of our normal sine. Okay, so increments can be anything. They don't necessarily just be in those convenient ones, but it can be. All right, so let's have a look at what happens with this. Now look, we could do a whole bunch of tables and things, but I want to try and build your intuition. Tables don't build intuition at all. Okay, so we want to build up some intuition. So what I want to get you to do is to draw sin x, because we've got half sin 3x. So let's just draw like we did for y equals x, y equals x squared. You know, we did all these. Every time we had one of these, we would do the baseline just to compare how we would draw the next one, you know? Or if we had y equals x squared, we would do the base one, just to remind ourselves what it looks like normally, so that if we get, this kind of thing happening, we can compare it, okay? So for here, this would seem like a reasonable thing to make a sine wave that is our base. So this is not testing table values, this is comparing. Okay, so we're just going to compare it with that one. We know that that's 2 pi, and we know that that's pi, and we've got our 1s, -1s, and pi. Okay, so we've got that. Now, this first one, we'll change the colour now. This first one has 2 changes. The first thing is it's only half the amplitude. There you go. So that's a half. Okay, that's a half. And minus a half. So it's only going to have max values at half and minus a half. Now we've got 3x. So we know the period is equal to, this is why in comparison, 2 pi divided by 3. Okay, now if we do it the way Jason's always taught you to do it, it's 2/3 of pi. Okay, so what we can do is come back to pi and divide it not into halves but into thirds. So there's our thirds. Okay, so the period is going to be 2/3 of pi. So this end point here is when this one finishes. So even before we've examined the table or looked at the value, we've said, interesting. The value at 0 is the end point 2/3 pi. 2/3 pi is 0. Okay. So we can put the other values in to get their y values. If you want to table a la a table, that's great. But I think this is more intuitive. So we'll just put our boundary across the top, because that's where it's going to come up to. And we notice that half of 2/3 is a third, and so we're going to draw our sine wave in. So our sine wave will come as 2/3, and we'll finish it early. So off we go. That's our maximum. So we just bring our beautiful sine wave up. And now that's actually incorrect, isn't it? Because it's got to finish. It's got to finish. See, that's the intuition. You've got to build your intuition, because it's one thing to build your tables. Now we want to halve those, because although that's our halfway point for our cycle, we're going to go up and down, aren't we? So we're going to go up, so maximum, and down in our half period. We're going to go to our other negative, and down and up. Okay, so these are very easy to see, because what are those values? You can check them. If that's 2/3 of pi, it's very, very easy to determine this halfway point, because it's simply a half of 2/3. Don't make it more complicated than it needs to be. Okay, a half of 2/3 is simply 2/6. Okay, or 1/3. Now we did it intuitively, simply by breaking up the divisions. The maths should match. Now you can put in your amplitude to show that that's 0. Okay. Now, if we go for this one, this is a half of pi on 3. So this one will be here, happening at a half pi on 3. So don't make it more complicated than it needs to be. Half pi on 3 will be pi on 6. Okay, pi on 6. So if you do those things there, what you'll find is that these values will make a lot of sense. Okay. Now we can check that with our technology. We love doing that. Okay, so let's do that with levels. Let's put in 1/2 sine 3x and y equals. Let's see what we come up with. So it gives you a little thing here, but there's a trick I want to show you with this. And because that's not much information, so it doesn't really help us. So let's change it to using a plot and then compare sine x. Or we can do it again. Y equals sine x. And then we put a comma. And that's the beauty of comparison. Okay, we're able to use comparison. Okay, so that allows us to check, look what's happening. Okay, so we've got our periods. There's our pi. There's our original one, the blue one. And then we've got our 1/2 sine 3x. That's the same thing there. Okay? Alright, so that's a very interesting way to do it. And so we can do that. Alright, so comparison, it's the same as ours. Right? It's the same as ours. Alright, the other thing that we've got here is minus 2 cos x on a half. So we'll just have to take our time and use your intuition. I'll use this graphic colour. So what we've got is the magnitude is minus 2. So we're going to be coming down here to minus 2 and plus 2. So that's plus 2. So that's the amplitude. So that'll be the point where we intersect with the peak value of this particular function. And down here it'll be the peak value of this particular function. Alright, the next thing we'll find is that we've got a period of a half. So please be patient, don't guess, just work it out. So we've got, this can be written as x times a half or half x. Just remember your algebra. So this is b, this one here is b. Okay, so this is 2 pi divided by b, and b is itself a half. So we've got to use our algebra for this. Okay, so 2 pi divided by a half. Okay, 2 pi divided by a half. Two pi divided by a half. Okay, 2 pi divided by a half, and we've learned to do this on quite a few occasions. So we've got 2 pi times 2 over 1. So our period is 4 pi. So we're going to be going all the way down here. So that's counterintuitive. We're going to finish later and come in at 4 pi. Okay, all the way down here. So that half has had a big impact on the nature of our graph. Okay, so we're just doing that. Now, minus cos is going to start us down here, and so we're going to work along. Now, we need to consider the halfway point. So that'll be our return to 0 point, and half of each of these. That'll be our... Now you can do this in table form. I guess what I'm doing in the graph is I am doing it in table form. I'm just doing it graphically. Okay, they're a similar thing. Alright, so we're going to swoop down. A cos wave would be swooping down and going down and up and swooping up. So this time it's going to swoop down all the way to pi. Look at that. All the way to pi. Wow. Because it's a negative cos, a negative 2 cos, then it's going to swoop all the way up, and then it's going to swoop all the way down, and it's going to swoop all the way down again, all the way down to there. Okay, so in effect, that's given us a big comparison. And we can work out each of those values simply by doing halves, quarters, etc. for each of our parts. So it's not a big problem, and you can see it visually. 2 is happening at 2 pi, minus 2 is happening at 0 and 4 pi. So sketching it out is important, and you can draw a table off that then. You can do the table first if that's what you want to do. I'm happy for you to do that. But in build your intuition up, that would be my request to you, to build your intuition up. Okay? So build your intuition up, and that will help you decipher what the question is looking for, and you can do that through your use of the calculations and comparison. So the last thing we've got is minus 2 cos x on 2. So let's add that to this list. So we're going to do comma minus 2 cos, I'll put it into brackets, x divided by 2 or a half x, and that's out. Oops, I didn't put a y, look at that. Y equals, so let's just do that again because it took it all as a thing. There we go. There's our third. Oh, look at that. So we started off and we had our parts there. So we're getting used to it, gaining experience. Nobody's expecting you to be a table wizard, computing all this stuff instantaneously at this point. You're still getting used to these curves and how these changes happen. Importantly, we're going to develop the next particular idea, and the next particular idea is related to what happens when you put an extra in. Okay, so we'll come back to that in the next video.